Joining me now is Mark Hersam. Thank you so much for being here today.
My pleasure.
And you are the recipient of the 2024 MRS Mid-Career Researcher Award. Congratulations.
Thank you.
So what has happened to the rate of improving performance of computers in recent years?
Yeah, there's two major factors. The first is power consumption. The faster you run a computer, the more power it consumes. And this is why clock speed is no longer mentioned as a metric when you buy a microprocessor, because it's stalled for the past 20 years due to this power consumption problem. Second major limitation is that the whole model of Moore's law is to make the transistor smaller, to pack more in per unit area. And we're now approaching atomic limits of further scaling. And as a result, that also limits computing performance.
So how can neuromorphic computing possibly circumvent this?
Right. So neuromorphic computing is modeled after the brain-like computing. The brain is orders of magnitude more energy efficient at computing than a digital computer. And there's two principal reasons for this. One is that a conventional computer uses a so-called Plan-Neumann architecture, where we have memory in one location, microprocessor in another, and then we move the data back and forth. That movement of data and the big data limit, the world in which we live today, leads to massive power consumption. In contrast, the brain co-locates memory and information processing, thereby minimizing the need for data to move, and that reduces power consumption. The second major difference is that the brain is a three-dimensional architecture, highly interconnected, whereas a digital computer is a planar two-dimensional architecture. So neuromorphic computing aims to take advantage of those two attributes of the brain.
So what's promising about using neuromorphic devices for machine learning and AI, which is big these days?
Exactly. So the whole concept of AI is to train your neural network on as much data as possible. The more data you give it, the smarter it gets. Which means this problem of moving data back and forth between the two blocks in a digital computer becomes exacerbated by artificial intelligence. And consequently, neuromorphic computing, by circumventing that problem, will allow for more energy-efficient artificial intelligence. Additionally, if we think about artificial intelligence as mimicking real intelligence, then we want to go after higher order cognitive function than what AI currently does. AI today is essentially pattern recognition. Real intelligence goes beyond pattern recognition. And if we're trying to mimic real intelligence, we should use a hardware platform that we know works, the brain. And as a result, neuromorphic computing will not only enable more energy-efficient AI, but more advanced AI.
Thank you so much, Mark, and congratulations once again.
Thank you.